So again, we're doing chapter 15 in itty bitty bits because I don't like probability, but it's all good. So today we're just going to talk about conditional probability. And so the first part of this is stuff that you could do without me. We already did it sort of in chapter 3. In chapter 3 we had contingency tables or two-way tables, and we could answer questions from the two-way tables. So we're going to do some of that. And then we're going to talk about what happens when you don't have a two-way table and you just have probabilities and how you can use a new formula to answer some questions. So, for example, here's a contingency table giving counts, and it has their students as gender and then their goal in school, whether that be good grades, to be popular, or to be good in sports. So, if we're going to go through and answer some of these questions. If we select a student at random, what's the probability we select a girl, just a girl? How do you figure out the probability that it's a girl? What's the probability that's a girl from the table? 251 over 478. 251 total girls over 478 total people. Right? You guys could do that without me having to say anything. What's the probability of selecting a girl whose goal is to be popular? Again, if we just select a student at random. The probability of selecting a girl who wants to be popular. What's that probability? (91 over 478), because again, we're just selecting a student at random. What about selecting a student at random whose goal is to excel at sports? Sorry. 90 over 478, no big deal. Then we also had questions in chapter 3 where it was a little more defined. So, what about a student that wants to excel at sports, given that we have selected a girl already? All right, so that means from the total number of girls, not the total number of people. So, want to excel at sports, given that they're a girl, then what's that probability going to be? 30 over 251. The girls that want to excel at sports out of just total girls. We define the population a little bit more. Questions about any of those? The first part of your assignment is just going to be using contingency tables to answer these types of questions. Now, you can't forget the things we talked about yesterday. So, for example, if it said, what's the probability of wanting good grades or being male, okay, just if we select a student at random, we want one or the other. That means we need the total number that want good grades, 247, plus the total number that are male, 227. But what else do we need to do? We did an OR question yesterday. Subtract out the overlap, right? So I need to subtract out the boys that want good grades because now they've been counted twice. And we don't want to count them twice. All right, so don't forget your rules from yesterday if you're asking those types of questions. Does that make sense? You're still adding sections together and subtracting out where they overlap. If it's just and, if it was a boy wanting good grades, then you just put 117 over 478. Don't overthink it. But if it says or, make sure you subtract out the overlap. Now, the part where it said, given that it was already a girl, we've got special notation for that in statistics, and we also have a formula for that in statistics. All right? We have the probability of an event B given A. That's what that bar means. It means given. That means there's a condition, and that's why it's conditional probability. If we're looking at that table, we said, what's the probability of them wanting to excel at sports given that it's a girl? We've now made more of a definition about who we're looking at. That means there's a condition on our probability, hence conditional probability. And again, we call that line something given something else. If you have the contingency table, like we just looked at, you don't need any formula. You just look at the table and you find out what you need, right? But you don't always have a table. Sometimes you just have percentages. Sometimes you have percentages in the table, So then you can't just add percentages together necessarily. All right, so we have a rule. The probability of B given A equals the probability of the intersection A and B over the probability of A. You could write that as the probability of both divided by the probability of what's given, if you want to think about it in English. You have to use this formula on the AP exam. I can almost guarantee you'll have to use it once. So it's on the formula sheet. It just has the letters reversed. It means the same exact thing. All right. So the one in purple is the same exact thing, just what's on the formula sheet. Do you have access to that during quizzes and tests? So let me give you an example about where this would be important to use. In a survey that they talked about in the book, they found that 56% of college students live on campus, 62% have a campus meal program, and 42% do both, campus meal program and live on campus. All right, so I have 3 percentages. I don't have a table this time. And it says, while dining in a campus facility open only to students with meal plans, you meet someone interesting. What is the probability that your new acquaintance lives on campus? So I'm looking for the probability that this person lives on campus given they have a meal plan, because I met them at a place that you have to have a meal plan to be at. Does that make sense? Does that make sense where I got given from? Even though it didn't say the word given. So, if you use the formula, what's the probability of having a meal plan and living on campus? %. What's the probability of what was given? So what's the probability of having a meal plan? 62%. And so you divide those, I think you get 67. You do. 68, you want to round. So 68% chance that the person that you met lives on campus. Question about how that formula was important. So the first part of your assignment will give you contingency tables. The second part will give you, like there's a cards question. Is everyone aware of what's in a deck of cards? 52 cards, 13 of each suit, 26 of each color. Just make it short. Sometimes this becomes a problem. So there is a cards question on the assignment. So like an example would be, what's the probability of getting a spade? Yeah, right now. Probability of getting a spade given that it's a black card. So you think about it with the formula. You don't have to think about the formula, but if I'm just practicing the formula. No. What's the probability of getting a spade that is black, or spades that are black? A spade and black card. It's probably getting spades and black cards. Both spades and black and intersection. How many spades are there? 13, and they're all black, right? So the intersection of spades and black cards is 13 out of 52. Divided by the probability of the black card. How many black cards are there? 26. So you get 13 out of 26, which is a half. That should make sense without the formula, right? That's why you get a spade, given you have a black card. Well, half of the black cards are spades. So that should make sense. But again, practicing with that formula. Okay? Questions? The assignment is on page 361, or 362, number 5 through 12.